Hi, good afternoon, Miles here, and today I'm going to be looking at a drill that has a reported electrical fault. This belongs to a friend of mine, and she passed this drill to me because she said it was malfunctioning, something electrical. She thinks it was to do with the switch, and I said I'd have a look at it for her. I have no idea what's wrong with it, so I'm going to take it apart and have a look, do some tests on it. It's a Black&Decker model KR500RE. It's a 500 watt mains powered drill made in England. I couldn't tell you how old it was. It does say 2001. That could be 2001, or it could be part of a manufacturer's number, something like that perhaps. But anyway, so it is. It's a hammer drill, reversible, I think. Yeah, reversible. No gears. Basic, straightforward drill, really. This particular drill was bought in mainland Europe. As such, it's got a European plug on it. It's the 2-pin unearthed variety. So it's been used with an adapter like this one for the 13 amp British plugs there, which is perfectly fine to do. You'll notice that the European plugs, they don't have a fuse built in. British ones do. There's a very good reason for that. The circuits in the buildings are different. So in Europe, the appliance level protection is done at the consumer unit or at the switchboard where the incoming supply is. That's where the appliance level protection is provided. In the UK we have different circuits. We've got ring circuits here where the protection's done in the device plug itself. So it's really important if you bring in an appliance from overseas that doesn't have a fuse in the plug, that you use an adapter that comes with a fuse in it. The one she's been using, this one here, it's absolutely fine. There's a 13 amp fuse in the back, so as you plug that through there, the 13 amp fuse protects the device. It's not necessary to do that in mainland Europe. You can just use that straight in the sockets there, but here you need the fuse. So that's an example of a good adapter. You can also buy a lot of really rubbishy type things from China like this, which are dangerous, illegal, and not at all recommended. There is no fuse in there whatsoever. So if you were to use this with this, it'll certainly work. I'll give you the connection, but there is absolutely no appliance level protection on there at all. The only protection that you've got of any kind is the trip switch at the consumer unit, which is probably going to be about 32 amps in this country. So that is dangerous and inappropriate and unnecessary, because these things on eBay, they're about £1. These things are about £1.20 or something like that. You know, for the sake of a few extra pennies, get the correct device. So I'm going to keep that on there. I shouldn't say a lot about what was wrong with it. It's just that it just wasn't working. So I'm going to pull it apart and have a look, see what I can find out. So the first thing I'm going to do to this device to give it a test is a series of electrical safety tests. We call them PAT tests in this country. And we might as well just see what kind of state the insulation's in and all the rest of it. This is a Class 2 device. It says, I don't know if you can see on the screen there, but you've got the double square there. That means it's a double insulator Class 2, which it must be anyway because there's no earth connection on the plug itself. Which I find slightly surprising because there are exposed metal parts, primarily the chuck. Well, only the chuck actually. Even so, I would have thought that would have been earthed. But never mind. Okay, that's how they've done it. So we're going to conduct a Class 2 test on this thing. Let's see what the insulation's like. Right, new test. Yep, is this right? Yep. Put test code, no. Automatic test, yeah, do automatic. Class 1 test, no, it's a Class 2 test. Visual check. Nope. Insulation test, just over 9.9 mega ohms, that is a pass. That's very good. Flash test, yeah, we'll do a flash test. Let's get the wand out. This is going to put 3000 volts onto the insulation. Pick somewhere where you might hold it, let's say the handle. Connect flash lead, press hash, yep. Yep, under 0.3 milliamps on the flash test. Let's do a flash test somewhere else. How about on the front here? Yep, under 3 milliamps. That's great. How about on the switch? Yep, under 3 milliamps, that's great. Load test. There shouldn't be any load because it's not running. Yeah, it's drawing less than 50 watts. Leakage test under 30 milliamps, it's a pass. Low load, check fuse, yeah, well, no, it's low load because it's not on. Test completed, pass. Okay, so that's a good start. We've got no glaringly obvious problems with it so far. So what I'm going to have to do is have a quick look at the flex itself. Quite often with devices like this you see that they can break just where the cable goes into the machine itself. It's a bit of a weak point. This has got quite a good strain relief on it. Can't quite see in there anyway, but it looks, what I can see looks alright. It was worth just spending a minute or two just looking at the cable, just feeling it, feel for any sort of abnormalities. It says it's a twin core 0.75 square mil. Seems appropriate for the device. Yeah, cable feels good. Can't feel any nicks or crushes, anything like that. The plug itself, the pins are tight. Yeah, it's in good order. So what I do now is plug it in and just see what it does, or probably more appropriately what it doesn't do. Alright, that's plugged in, so let's have a look. It turns. That's good. I was told it didn't work. Can we change direction? Okay, well that seems to function to me, despite being told that it didn't work. So what I'm going to do is take the cover off and have a look. Could be there's like a wire on the back of the switch that's a little bit temperamental, coming loose, something like that. See if I can get to the bottom of it and work out why this doesn't seem to be working as the owner would intend. The screw heads are posi drive 2. So let's just pop them out. Comes apart nice and easily, like that. He says, knowing that it might not in a minute. This drill is very similar to my first drill. Well, my first drill was a lot older than this one, but it was a Black&Decker of about this size. Don't know what became of that. Sometimes you get screws underneath the sticker. There seems to be anything there. Should just pop open now, hopefully. There we go, yep. Oh, there we go. Let's take the cover off. And it's quite tidy inside. A little bit of dust. Mechanism feels good. Let's have a look at some of the wiring, just to see everything's tight. And we'll start with the switch. Yeah, they feel tight. These are just those push in and it clamps types of fitting. I'm not generally a massive fan of those. I don't think they bite as well as ones with screws. On the incoming side, looks okay. The live side, let's have a look. Don't know what this little white plastic thing is. It seems quite stuck in there. Anyway, and that seems happy to pop out whenever it likes. Maybe this plastic thing's a release for them. Oh yeah, see they come out easily then. Now I can see the flex within the grommet. I can have a better look at it. I mean, that looks fine to me. Oh, there's damage there. There's obviously a kink in it, but it's supposed to be there. In fact, while that's out of the way, I'll look at this little capacitor here. It is a 0.22 microfarad capacitor. Seems fine. There's a wayward strand there. That didn't get crimped as it should have been. Let's remove it so it can't stray over to the neutral. I guess that on the top is the reversing circuit. The wires are quite tight. Looks perfectly well engineered. No issues with that really, from what I can see. That's it. Sure these wires are in the conduit there. Everything electrical to me looks quite tight. The bushes are a little dirty, but fine. You know, I've seen a heck of a lot worse than that. There's good pressure on the springs. Can't see an awful lot wrong with this drill, if I'm perfectly honest. Should have a close look at the switch perhaps. Suppose I could dismantle the switch and have a look at that. Let's take the flex off it then. Let's have a closer look at the switch itself. She did say she thought it might be the switch. Although how she concluded that, I don't know. It's a Dutch switch made by Capax. See, so it goes in and that locks it on, and that releases it again. Okay. Well, the switch can be dismantled. I think we've got it. Oh, there's a tiny little circuit in it. That's pretty cool. So as the switch advances, this one makes contact first, then this one. And these two contacts here meet the two contacts on the circuit board there. I can't see anything obviously wrong with it. There's a bit of arc damage to the contacts that you're never going to see on camera. Contacts are quite dirty underneath from all the arcing that it would have been doing over the years. But really nothing too significant. Looks like it's doing what it's intended to do. You can just clean the contact a little bit with the tip of the screwdriver. Help a little bit. And that one. So when that switches in, how tight is that? Feels quite loose. That might well be an issue. I've also got these contacts here. They're clean enough. So I guess when this pushes in, the circuit runs between these two contacts. It'd be worth putting the multimeter on that, seeing what the continuity is like. Hopefully you can just see on the screen there my multimeter. The resistance there set to a scale of 200 ohms. Touch the pins together, it'll go down to almost zero. Okay, half an ohm. That's appropriate. I'll try and get it so you can see the screen a bit better. There's a bit of a sweet spot in this that's difficult to find. Yeah, that's not much better. There we go. Anyway, okay, so it'll move in a minute, I expect. So probes together, that's showing almost zero. It's really just the resistance in the probes themselves there. So let's have a look at this this fitting here. Let's move this out of the way a minute. So if we were to test that now, what do we get? No continuity, as you would expect. No continuity there either. This is going to be tricky to do with not having three hands. So as that switch goes in, do we get continuity then? Not on that one. Not on this one either. I would have thought there would be. Let's push it all the way in. That's strange. Wonder if half the problem is I'm not able to hold it tightly. Push it in halfway. Okay, it feels firm there. Okay. Let's try again on this contact. Nothing at all. See if we can find a continuity anywhere on any metal part there. No. Yeah, I'm possibly misunderstanding how this is supposed to work. Okay, got continuity there. Oop. There's really not much holding these clips on. I should use the probes that I've got with crocodile clips at the end. It might be a bit easier. Okay, so as soon as the switch goes forwards, the little contact in there closes. To me it doesn't seem like it's very enthusiastic about the current going all the way to the contact. There's nothing there. Okay. Next thing to do, I suppose, is take the switch out. Right. Yeah, it would be easier without the capacitor, I think. Take that over there. How would one remove that? These things are going everywhere. So as that moves, it relies on the current flowing from those pads there onto these pickups down to a contact there that rests on the switch, this sort of flip-flop micro switch thing. Which then contacts the pad there, so we just turn that over so we can have a look at what the other side looks like. It's quite fiddly. Yeah, that contact is quite dirty. Give it a bit of a clean. It's extremely fine. Sandpaper would work well with us. Now I can get to that contact better. I can just scrape some of the soot off it, and it's not really soot, but it looks like soot. Okay. Looks a lot cleaner now. It's amazing how a drill like this, it all comes down to such a tiny little piece of engineering like this. They're the size of watch parts, they really are. What we can do to aid contact is obviously that's sprung loaded there. It's possible, given this thing might be 20 years old or more, that that's just fatigued a little bit, so it's not contacting so well. So what we can do is just bend it back out a little bit, not too much, just so when it comes back onto there it's more of a positive connection. Allow the current to flow better. Maybe bend it a little bit more. Do the same with this one. This one's less important. It's a lot cleaner looking. This is the one that tells it that the trigger is fully pressed in. Again, we can do the same with these. These are possibly fatigued. They're very, very thin copper or brass. And brass. Bend them up a little bit. And hopefully that'll help. They're certainly clean. No issue there. There's a bit of dust in it. Nothing too bad. There's a little bit of grime on the contact there. It's probably not helping. Scrape that away a little bit. I'll just get this back on. It wasn't easy to remove, it's probably not going to be easy to put back. Does this come out? There we go. There's a little gasket there, a little rubber gasket. Trigger back on. Got ya. So I put the switch back together, all the little tiny pieces in there. That took me about 20 minutes. 20 minutes of my life I'll never get back. Let's put the cover back on. Watch it all spring apart now. No, there we go. Well, I failed to really find anything glaringly obviously wrong with that switch. There did seem to be a bit of a continuity issue on some of the contacts, but I think I'd misunderstood the way the circuit was supposed to be tracked across the device. It seems to function, as far as I can tell, as intended. So what I've done is I've cleaned the dirty contacts, and where some of the springs were becoming loose, where they were fatigued, I bent them back to give them some fresh pressure, so that everything's tighter now. Hopefully that'll work better. Okay, let's put it back in the drill, power it up again, and see if it is still performing as it should, or whether it's giving any indication as to what the problem is. In with the neutral, in with the line. Come on. Okay. What I'm going to do now is just connect the power to that. Also being quite careful at this point because there's live electrics in there. Holding the switches thus, see what it does. Okay, just unplugging it again. I'm afraid I really can't see an awful lot wrong with that. It's possible the switch was being temperamental, that's why she's given it to me, but it seems okay at the moment. I might just go and fetch a bit of sewing machine oil just to lubricate the piston a little bit. I have here some Singer super oil it's called. It's basically a light machine oil used for well, all the things you can see on there really. I call it so machine oil because I think that's what you generally refer to it as, but it's good for anything like this. So just a very light machine oil. So I just put a dab on the piston there. And the tracks. Oh, that feels nicer. Let's put a little bit in the bearings of the rotor there. At the back. Put a bit in the fan bearings down there. One thing I'm tempted to try with this is a little bit of a fiddle with this cable here, just in case we've got an issue with that. Because I've had a couple of drills in the past where the kink actually has a minor break in it that doesn't always show itself. Let me just power it back up again being careful. Right, that's now energised. So what I'm going to do is set the motor running and lock it down and then fiddle with this cord and see if that makes any difference, see if I can get it to stop. No, there's no break in there. Unplug it again. This drill was handed to me in an inoperable state, and I have to admit I cannot actually find anything wrong with it. I think it's in quite reasonable condition actually. I have to admit I just can't find anything wrong with that. I shall give it back and ask for more information. Oh, I've just noticed something. Schoolboy over there. Strain relief grommet. It's popped out while I was tightening it up. Just loosen it off a bit. Back in you go.